Okay. So yesterday we had discussed some important concepts based on quadratics and functions, right? Now, today we are going to discuss some more of them. Uh, okay. Okay. So yesterday we had seen that mod of fx is discontinuous. Sorry, not discontinuous, is not differentiable at fx equal to 0. But if I have mod of fx to the power n, now what happens in that case? So for example, if I have mod x squared or mod x cube or mod x to the power 4, now are these differentiable at x equal to 0? So if I functions, so these functions would be of the type x square slash minus x square, x cube, x square and minus x whole square, which would be x square and x square. This would be x cube and minus x cube. This would be x4 and minus x to the power 4, which is x4, and so on. So this is on the positive side, this is on the negative side. So that means if I take the differential on, I will get 2x, 2x. Here I'll get 3x minus 3x square minus 3x square. Here I'll get 4x cube and 4x cube, right? So regardless of the power, right, all these functions will be differentiable at x equal to 0 because the left hand and the right hand differentials will be all 0, right? But in case of mod x, this becomes x and minus x. So this is 1 and minus 1. So this is not differentiable at x equal to 0 because the differentials on the positive side and the negative side are different. So that means if you are given a function of the form mod x mod x square plus mod x cube all the way up to mod x to the power n, and you are asked whether this function is differentiable for any value of x, whether this function is differentiable at all points, then the answer is this function is not differentiable at x equal to 0 because of the first one. This is not differentiable at x equal to 0. So if you are given a function of the form a0 mod x plus a1 mod x square plus a2 mod x cube, etc., up to uh, a n mod x to the power n plus 1, then this, this function will be differentiable for x being a real number if a0 is equal to 0. Okay. Next. Now, if you have a quadratic which has real roots, then the important conditions that can be applicable are uh, this, if A equal to C, roots are reciprocal to each other. This one is important. That means if A and C are of opposite signs, the roots are of opposite signs because alpha into beta is C by A. So if A and C are of opposite signs, the roots are of opposite signs. And if all three of them are either positive or all three of them are all negative, then both roots are negative, right? So this is another important criteria. And if the sign of A and C are the same and B is different, then both roots are positive. Okay, this is important. If the sign of A is equal to the sign of B and not equal to the sign of C, then the greater root in magnitude will be negative. And if the sign of B is equal to the sign of C and not equal to the sign of A, then the greater root in magnitude will be positive. And if A plus B plus C is 0, that implies one root is 1 and the second root is C by A or minus B minus A by A. So these are some of the important uh, criteria for defining the nature of the roots. If you have irrational roots, that means A, B, and C are all odd. Only then you will have irrational roots, right? And if you have irrational roots, one root would be the conjugate of another. So if you are given that 2 plus root 3 is a root of ax square plus bx plus c, this means the other root has to be 2 minus root 3. Okay. Similarly, for imaginary roots, if one root is imaginary, then the other root will be its conjugate. Next, if two quadratics have one common root, then the condition for that is this one. That means C A dashed minus C dashed A is the geometric mean of A B dashed minus A dash B and B C dashed minus B dash C. That means the equations are the same, which means A by A dash will be equal to B by B dash will be equal to C by C dash. Okay. Now we move to concepts on binomial theorem. Now, you know that A plus B to the power n equals nc0 into A to the power n plus nc1 into A to the power n minus 1b plus nc2 A to the power n minus 2b square all the way up to ncn b to the power n. Now, in place of A and B, if I have 1 and x, then this becomes nc0, and we write this as omit the n. We write this as c0 plus c1x plus c2x square all the way up to cn x to the power n. So which means if x is equal to 1, then we get 2 to the power n equals c0 plus c1 plus c2 all the way up to cn. So that means the sum of all the coefficients of the terms in the binomial expansion will be equal to 2 to the power n. This is one important result. The other important result is if x is equal to -1, then 0 equal to C0 minus C1 plus C2 minus C3 all the way up to Cn into minus 1 to the power n. So that means the sum of the odd coefficients will be equal to the sum of the even coefficients. So that means C0 plus C2 plus C4, etc. will be equal to C1 plus C3 plus C5, etc. And this will be equal to 2 to the power n divided by 2, which is 2 to the power n minus 1. So this is the second important result. The third important result is if I put 1 plus x to the power n equal to C0 plus C1x plus C2x square up to Cn xn, and I put x plus 1 to the power n equal to C0 x to the power n plus C1 x to the power n minus 1 plus C2 x to the power n minus 2 up to Cn into 1. Then if I multiply these two, I get 1 plus x to the power 2n equals, I take the terms which are the coefficient of x to the power n. So here I get C0 into C0 square, C0 into C0, which is C0 square, plus C1 into C1, which is C1 square, plus C2 square, plus all the way up to Cn square into x to the power n plus other terms. Now, on the other side, the coefficient of x to the power n would be 2ncn into x to the power n. So that means the sum of the squares of the coefficients will be equal to 2ncn. C0 square plus C1 square plus C2 square all the way up to Cn square is 2ncn. So these are three important results based on binomial. The other important concept in binomial theorem is what would be the greatest term in a binomial expansion. So the greatest term, the magnitude of the greatest term will depend on the value of a and b. So if a plus b to the power n is the binomial, then the value of n plus 1 by 1 plus mod of a by b, if this is an integer, let's say m, then the mth term and the m plus 1th term will be the numerically greatest term. Because if you calculate the value of the r plus 1th term and you assume that the r plus 1th term is the greatest term, so it should be greater than both the rth term and the r plus 2th term. So from there, if you solve these two inequalities, you get this result. That means r has to lie between n plus 1 over 1 plus mod of a by b minus 1 and n plus 1 over 1 plus mod of a by b. So this would be the range of values of r. Now, if this itself is an integer, then this will become that integer minus 1. So in that case, r will lie between m and m minus 1. So that means r can take two values which are m and m minus 1. Therefore, r plus 1 will become m and m plus 1. So these two terms will be numerically the greatest in this expansion if this value is an integer. So which means the magnitude of these two terms will be the greatest. And if this is not an integer, then obviously this will lie between n plus 1 by 1 plus mod of a by b and n plus 1 by 1 plus mod of a by b minus 1. So that means suppose this is not an integer. So suppose this is 2.5. So this will lie between 2.5 and 1.5. So the only integer value of r can be 2. So that means r would be equal to 2 in this case, which would be the integer value of this part. So therefore, tr plus 1 would be equal to t2 plus 1, which is t3. That means the greatest term will be the m plus 1th term, where m is the integer part of this one. Okay. Next, we move to some other important concepts. First one is in case of permutation and combinations. Now, let's say I have n objects and I want to divide n objects to be divided into R groups such that no group is empty. So let us take an example. I have, let's say, 7 chocolates. I have 7 chocolates to be divided among 3 kids so that each kid gets at least one. Now, how am I going to do this? So I have 1, 2, 3, 4, 5, 6, and 7 chocolates. And I have to divide this into 3 uh, parts or 3 groups so that each group has to contain at least one. So that means I will look at how many spaces are there. So if there are 7 chocolates, then there are 7 spaces between them, right? And I will take a stick or a ruler, and I can put that ruler in any of these 6 vacant spaces. So suppose I put it here. The next one, I can put it in any of the 5 remaining spaces. So suppose I put it here. So that means I have divided this into 3 groups where the first kid gets 1, the second kid gets 3, the third kid gets 3. I could have also put the first barrier here, the second barrier here, and that would have divided into 3 groups where the first kid gets 2, the second kid gets 4, and the third kid gets 1. So that means essentially what am I doing? Essentially, I am looking at the gaps between the chocolates or uh, the spaces between the chocolates, and I'm putting one barrier there to divide them into groups, right? So I need 2 barriers to create 3 groups. So 2 barriers are required to create 3 groups. And there are 6 spaces to place the 2 barriers. So that means I have to choose 2 places out of the 6 places to put the 2 barriers, which can be done in 6C2 ways, which is 6 into 5 by 2, which is 15 ways. So therefore, 7 chocolates can be divided into among 3 kids so that each kid gets at least one in 6C2 ways. And how am I getting 6C2? I am subtracting 1 from the number of chocolates that I have. So 7 minus 1 C, and I'm subtracting 1 from the number of kids that I have because to divide it among 3 kids, I need 2 barriers. So 3 minus 1. So if I have to do the same thing with n objects and R groups, then the way to do that is n minus 1 C R minus 1. Okay. Next. Uh, Arrangement of letters. So let's say I have, if I say in how many ways can the letters of the word arrangement can be arranged. So here I have to see how many letters or how many alphabets are being repeated. So I have A repeated twice, then I have R repeated twice, then I have N repeated twice, and I have uh, E repeated twice. So I have four letters which are repeated twice. So that means I will form groups of these letters. So I will form groups of AA, RR, NN, EE. So these are four groups, right? And then I will be left with G, M, and T, right? So basically, I have 7 entities, right? So, so if I had only one A, one R, one N, and one E, and one G, one M, one T, I should have been able to arrange them in 7 ways, right? Right. But here I have repetition of A, R, R, N, N, and E. That means I can arrange them in factorial 7 divided by factorial 2 into factorial 2 into factorial 2 into factorial 2, because these are being repeated. Okay. Okay. Next concept is um, concept of uh, all possible uh, all possible arrangements. So let us say uh, how many uh, numbers can be formed with the digits uh, 0 to 9. Okay, where no digit is repeated. So that means I have to start from 1-digit number. So if I want to form 1-digit number, there will be 9 of them. If I want to form 2-digit number, that means the first digit can be filled in 9 ways. I cannot have 0 in the first place, and corresponding to that, I can fill the second one in 9 ways. So 9 square. Just give me 1 second.
Sir?
Hello?
Sir?
ঠিক আছে। Oh. ঠিক আছে। Okay. Sorry. So a 2-digit number can be formed in 9 into 1, which is 81 ways. A 3-digit number can be formed in 9
Sir?
into, yeah.
So in the previous example, we are dividing with the 4 times. Sir, is it required to divide it 4 times? Because we are not counting A, R, R at twice. So we have already taken 7 letters.
Oh, sorry. Thanks for pointing it out. This is not 7. My mistake.
Sir,
This
it should
would
be
be
11 now.
yes. 8 and 3, 11. Sorry, my mistake. This would be 11 factorial 11 by factorial 2 into 2 into 2 into 2. Sorry. Okay. So this would be 9 into 8, which would be 9 into 72. Similarly, the 4th digit would be 9 into 8 into 7. So this would be 9 into 9 into 8 into 7 and so on. And the last one that I can have is a 10-digit number, where would be 9 into factorial 9. In case of a 9-digit number also, it would be 9 into factorial 9. And the rest of them will go like this. So that means if I add all of this up, then the total will be 9 plus 9 into 9 plus 9 into 9 into 8 plus 9 into 9 into 7 into 8 into 7 and so on up to 9 into factorial 9 into 2, right? So now if I want to calculate this, so this is 9 into 1 plus 9C1 plus 9C2 into 2 plus 9C3 into 3 and so on up to 9 into 9 9 into 9. Into 2. So this would be the form of the number of numbers that can be found with this number of digits, right? Okay. Next. Next, I go to the concepts of geometry. Okay. Triangles. Now, if I have a triangle where the sides are mm, A, B, and C, right? And it is given that A, B, and C are integers, and A is equal to 10, C is equal to 20, then how many such triangles are possible? How many such triangles are possible? So we know that any side of a triangle will be greater than the absolute difference between the other two sides and less than the sum of the other two sides. That means B has to be less than 30, greater than 10. So which means B has to lie between 29 and 11. So the number of triangles that are possible are 29 minus 11 plus 1, which is 30 minus 11 or 19. Okay. Okay. Uh, Once again, I have a triangle where the sides are a to the power n, b to the power n, and c to the power n, where n tends to infinity. Okay. What kind of a triangle will this be? So if n tends to infinity, right, we know that if I take any side of the triangle, a to the power n will be greater than b to the power n, a to the power n will be greater than b to the power n minus c to the power n, and less than b to the power n plus c to the power n, right? Now, let us assume a greater than b greater than c, greater than equal to b greater than equal to c, right? Now, if I divide this inequality by a to the power n on both sides, I will get b by a to the power n plus c by a to the power n will be greater than 1, right? And if I take the other inequality and I divide both sides by a to the power n, I will get this is greater than b by a to the power n minus c by a to the power n. Now, since b is greater than c, the absolute value is b to the power n minus c to the power n itself, right? So that means b to the power n, b by a to the power n minus c by a to the power n is less than 1, right? Now, what happens when n goes to infinity? Both these values, as n tends to infinity, both b to the power a to the power n and c by a to the power n, they will go to 0, right? So that means this inequality will become invalid, will become invalid if n goes to infinity, because this will become 0 greater than 1, right? Which becomes invalid. So that means this can be only valid when b is b by a is equal to 1. That means b is equal to a. Clear? So that means this triangle has to be an isosceles triangle. So if you have the sides of a triangle as a to the power n, b to the power n, c to the power n, where n tends to infinity, then the triangle has to be an isosceles triangle. Only then the left-hand side inequality will hold true. In a triangle, if a square is greater than b square plus c square, what kind of a triangle is it? Where a is greater than b greater than c. What kind of a triangle will it be? Now we know a square equals b square plus c square minus 2bc cos a, cosine rule. That means if cos a is positive, then a square will be greater than b square plus c square, right? No, sorry, my mistake. If this is positive, then b square plus c square will become greater than a square, because in that case 2bc cos a is positive, you move it to the other side, so b square plus c square is equal to a square plus 2bc cos a. So that means b square plus c square will be greater than a square, right? Which means cos a greater than 0 means the triangle is acute angle. That means in an acute angle triangle, the square of the sum of the squares of the two smaller sides is greater than the square of the third side. And if cos A is less than 0, that means A is greater than 90, which means triangle is obtuse. Then a square becomes equal to b square plus c square plus 2bc cos a. Cos a being negative means this part will become positive. So then a square will be greater than b square plus c square, which means in an obtuse angle triangle, the square of the largest side is greater than the sum of the squares of the other two sides. Okay. Okay. If the incenter and the circumcenter of a triangle lie on a straight line, then the triangle will be what? Incenter and circumcenter of a triangle lying on a straight line. Incenter, circumcenter, and centroid lying on a straight line. If these are collinear, then what would be the triangle? What kind of a triangle will it be? So in any triangle, the circumcenter, the centroid, and the orthocenter lie on a straight line. This is true for any triangle. And this line is called Euler's line. And the centroid divides this line in the ratio of 2:1. So circumcenter to centroid is to centroid to orthocenter will be in the ratio of 2:1. And in isosceles triangle, the incenter also lies on the Euler's line. That means if the incenter, centroid, circumcenter of a triangle are collinear, then the triangle has to be isosceles. Okay. Next. Uh, if there are three balls or three spherical objects placed in a conical, placed in a cone, and if the radius of these three are R1, R2, and R3 respectively, then the relationship between R1, R2, and R3 is R2 is the geometric mean of R1 and R3. That means R2 square will be equal to R1, R3. Uh, in a circle, if there are two chords AB and CD intersecting at E, then AE into BE is equal to CE into DE. This is one of the important properties of two intersecting chords. Uh, okay. if I have a right angled triangle and if ABC and if BD is the perpendicular from the right angle to the hypotenuse, then the maximum value of BD will be AC by 2, half the hypotenuse, right? If uh, there is an n-sided regular polygon such that uh, the product of its side and the perpendicular distance between the opposite sides. There is a n-sided regular polygon uh, where n is even, such that the product of its side and the perpendicular distance between the opposite sides is 1/8 of the um, area of the polygon. Find the number of sides. Now, if we have a n-sided polygon where n is even, so for example, I start with a hexagon. Now, if I have a hexagon, then this would be my perpendicular distance between the opposite sides. And this hexagon can be divided into 6 triangles. Because it's a hexagon, there will be 6 uh, triangles of equal area that will exist in this, right? So if I consider the area of each of these triangles as x, so that then the area of the hexagon will be 6x. Now, if I look at the rectangle found by the perpendiculars between the opposite sides and the sides themselves, then this this rectangle consists of 4 triangles, 1, 2, 3, and 4. Now, 1 and 2 will have the area of x. What about 3 and 4? Now, in this triangle, you can see that the I name this ABCD. So, in the rectangle ABCD, the diagonals bisect each other. So, in the triangle ABD, let's say this is E. AE is the median of ABD. That means AE will divide ABD into 2 equal parts. So, if one side is x, the other side will be x. Similarly, D is the median of ADC. So if triangle ADE is x, this is also x. That means the product of the side and the perpendicular distance between the opposite side is 4x. So that means the ratio of this to the area of the hexagon is 4x by 6x, which is 2 by 3 in this case for a hexagon, right? So for a hexagon, I get this as 4 by 6, right? So now in the given question, it is told that this ratio is 1 by 8. So that means for uh, an n-sided polygon, there would be n number of such triangles. So that means the total area would be nx, and the area of the rectangle will be 4x. So this would be 4 by n for an n-sided polygon. So that means 1 by 1 by 8 is equal to 4 by 32. So that means the value of n is 32. So it will be a 32-sided polygon. Okay. So we've covered functions, we've covered quadratics, we have covered uh, circles, triangles, permutation, binomial. Okay. Uh,
Sir, can you please explain properties of two circle inside a cone?
yeah. Okay. So this is not only applicable to a cone, this is applicable to any uh, any kind of figure where the sides of the figure will be tangent to both the circles. That is the concept, right? So that means so if this is R and this is small r, then if I join these two and I extend it, this will be the the bisector of this angle, right? Right.
Yes, sir.
So that means if I consider this angle to be theta, so I just equate the two similar triangles. So I have r by r will be equal to the distance. Uh, let's say this is x, this is p q, right? So r by r will be px by qx, right?
Yes, sir.
And what is px? Px is pq plus this point is pqxy. So px is equal to py plus xy by qx, which is qy plus xy, right? Right?
Yes, sir.
And we know that PQ will be, this is R, this is small r, this is also small r. So PQ will be R plus R, and PY would be capital R plus 2 small r. So capital
Hmm.
R by R will be PY, which is capital R plus 2 small r plus XY by QY, which is small r plus XY, right?
Okay, sir.
And you do a component to dividend on this. So this will be equal to numerator minus denominator, right? By numerator plus denominator. You can do it either ways. So numerator plus denominator would be r plus 2r plus r, which would be capital R plus 3r plus 2xy, numerator plus denominator, by numerator minus denominator will be r plus 2r minus r will be r plus r, xy will cancel out. Clear? Clear?
Yes, sir.
And you do the same thing here. So numerator plus denominator would be r plus r by r minus r, correct?
Yes, sir.
So that means you cross multiply now. So you get r plus r whole square equals r minus r into r plus 3r plus r minus r into 2xy, right? Right? So you transpose this to this side, you get r plus r whole square minus r minus r into r plus 3r by r minus r into 2 would be equal to xy. Clear?
Yes, sir.
So now you look at uh, these two triangles, these two circles where you have capital R and small r, right? So now just draw a perpendicular from here to here, right? So if you draw a perpendicular from this to this, what do you get? You get a rectangle, right? Or you can draw it the other way around, whichever is convenient to you. So this is 90 degree, this is 90 degree, right? So if you draw a perpendicular from here to here, this forms a rectangle, right?
Yes, sir.
And this would be the hypotenuse of the right angle triangle here. So r plus r whole square will be equal to this, which is capital R minus small r whole square plus this distance, right? which is, let's say, AB, right?
Yes, sir.
So that means AB square is equal to 4R into small r, right? Right?
Yes, sir.
Which will be equal to this distance out here. So now if you take, uh, these two triangles, triangle XQB, right? You have QX plus QX square plus QB square is equal to BX square, right? Either you can do it that way or you can do a tan theta here. Tan theta will be small r by this distance. So tan theta will be equal to small r by qx. And you already know the value of xy in terms of r and r, right?
Sir,
And
maybe it's bx, r by bx.
tan theta, you can do sin theta also, right? Doesn't matter. You want to do r by bx, that would be sin theta, right? Oh, no, sorry, my mistake. This is the right angle, is here. R by bx, correct. R by bx is tan theta, and this is equal to capital R by x, right?
Yes, sir.
And uh, from this, you get ax by bx equals R by R, right? And
Yes, sir.
ax is equal to ab plus bx upon bx equals R by R, right? And AB is root over 4R into R. So that means root over 4R into R by BX plus 1 equals R by R. Clear? Clear?
Yes, sir.
So from here, you can find BX in terms of R and R, small r and capital R, right?
Yes, sir.
And
Actually, this property is used in a previous year question. I was confused, but I can solve it now.
yeah, so okay, instead of uh, drawing it like this, I think I should have drawn it horizontally. That makes life a little easier. So if you draw it like this, then this is your circle 1. This is your circle 2. It's easy to visualize in this. So this is your capital R, this is your small r. So that means this distance plus this distance, which is r minus r, and this distance will be r plus r. So this distance, if I call it as d, so d square equals 4r into r, right? Right? Right?
Yes,
And
sir.
if you join this, then if this angle is theta, then this angle is also theta, right? So that means uh, minus r by uh, by 4 square root of 4 r into r will be equal to tan theta. So d square is equal to 4r into r. This you know how it came. It is r plus r whole square minus r minus r whole square. From there, d square is 4r into r. That means d is 2 square root of r into r. So r minus r, which is this, by this, which is d, 2 square root of r into r is equal to tan theta, right? Right? And since you are given the cone, this angle will be told to you. Okay. So basically, you know theta, tan theta, and one of the two will be given, either capital R or small r, and you have to find the other one, right? So suppose, for example, if theta is given as, if the full angle is given as 60 and theta is 30, then this equation will become r minus r equals tan 30, which is 1 by root 3 into 2 root over r into r, right? Now you square both sides, you get, basically we'll have to solve a quadratic here. You square both sides, you'll get r square plus r square minus 2r into r equals 4 by 3 r into r. So that means if suppose r is given, then the quadratic will come out in small r. So r square minus 2r into r minus 4 by 3. That means minus 10 by 3 r into r plus r square equal to 0. Correct? So this would be a quadratic in small r. So use the quadratic formula, solve for small r. Clear?
Yes, sir.
Okay. So this is the way that you solve these kind of problems. Okay. Either you can go with the distance formula, which will be a little, you know, little more tedious. But if you apply tan theta or sine theta, that becomes much easier. You go for a similar triangle, apply tan theta or sine theta, you straight away get an equation with r, and theta. Okay. Okay, so
Thank you,
that's
sir.
all for today, and we'll have 2 more sessions. We'll do some more revisions of concepts uh, that that are important from your exam perspective. Okay, take care. Bye.